Question 19 is basically another equilibrium ionization, equilibrium calculation where we're going to calculate the concentration of H plus, because what it asks for is what's the percent ionization. And percent ionization is defined to be the amount of H plus that is formed from a weak acid divided by our starting concentration of HF, of course, then times 100%. So that's all we have to do is calculate what the H3O plus concentration, plug it in, divided by the original HF concentration. So here we start with 0.337, so that's our initial concentration. That's 0, that's 0. Our change is going to be minus X plus X. And so our equilibrium concentration, 0.337 minus that X, and this is going to be X times X. So Ka here is equal to 3.5 times 10 to the minus 4th. That's equal to X squared divided by 0.337 minus X, but K here is 10 to the minus 4th, so that's going to be small, and our arithmetic ends up being 0.337 times 3.5 times 10 to the minus 4th equals X squared. So I take the square root of both sides, and I obtain, so my X equals the H plus concentration, and that turned out to be 0.011, so that's a 1 there, okay? And so my percent ionization is going to be 0.011 divided by my starting concentration, 0.337 times 100%. So question 20, which of the following bases is the weakest? So a weak acid will not increase H plus concentration very high, and a weak base will not increase OH minus concentration very high. So that means when I put a base in water, which one produces the smallest amount of OH minus? Well, it goes back to looking at the equilibrium constant, right? OH minus concentration times HB concentration over the base concentration. And so the one that's going to be the smallest amount of OH is going to have the smallest numerator, and therefore it's going to be the smallest KB. So up here, 10 to the minus 9, 10 to the minus 4, 10 to the minus 5, 10 to the minus 5. This one is the smallest KB, therefore it's going to be the weakest base. So question 21, the dissociation, base dissociation constant, KB, is 6.4 times 10 to the minus 4th. And the H plus in a solution, oh, I didn't copy out what the original concentration is here. Let me get that. So that concentration for the ethylamine starts at 1.6 times 10 to the minus 2 molar. And so this is an equilibrium calculation, right? So initially, this is what we're starting with, 0 and 0. And then we're going to have our change, which is minus X, X, and X. And this is going to be the equilibrium concentration, 1.6 times 10 to the minus 2 minus X. And that's going to be X, and that's going to be X. Now, I'm pretty short on time on this video, so I just worked through these steps, wrote out the expression, did the multiplication, it came out with my OH minus concentration. Now, this question asks for the H plus, so we've got to do that multiplication. So if you follow through with this multiplication and then solve for H plus, this is the value you get out for that hydrogen ion concentration, which is the answer to this problem.